we will share our presentation slide. Okay, wait a minute. Where is those? Where is those? Okay. Okay, can you see this slide? No?
Can, sir.
Yeah, so this is what we discussing last week. All right. We have discussed about what is if someone wants to establish a project. All right. So he needs to have defined the scopes. Okay. And then try to balance the priorities. Okay. So that he can achieve the scopes. Okay. And then once you got commit scope and priorities, you at your best try to creating your work breakdown structure, so that by doing this work breakdown structure, or we call those as the WBS, you can catalog your scope and also your priorities, and you also can integrate the WBS together with your own organizations. Okay, so once you got this kind of integration, you can coding the WBS with your information system. So this is what we already discussed last week. Okay, up until how people develop the WBS. So for today, we would like to continue our knowledge sharing. All right, about the WBS. Okay, wait a minute. Stop presenting here. I would like to share another content. Okay, so for today, we would like to continue our lesson for this part B. Okay, establishing the project. Can you see the slide now? Part B.
Yes, sir.
Yes, sir.
Yes, sir.
So this part B will be discussing more on the WBS, first one, and then the second one we will discuss about the activity on not NOD. All right, so that you can establish your project in a systematic way. Okay, the first one is creating the work breakdown structure or WBS, and then the second one about the NOD, activity on not. All right, so for today, we will start. Okay, we will start our discussion regarding of the WBS, work breakdown structure. So this WBS, until last week, we learned how people evaluate the project scope. Okay, and then maybe you can integrate your cost or bill of material. Okay, BOM, bill of material, and then time or schedule. Okay, why we need to integrate this? Because once you work as engineer, time is the among the most critical item that you need to taken care of, because you are facilitated to what we call it as the product life cycle. You do not want to become late. Okay, you need to marketing. Okay, you need to evaluate and distribute your product as fast as possible to the market, to the public, to the citizens. Okay, and again here the WBS here is also a technical performance of the organizations on a project. So it will give you proper information, okay, as a channel for communication between you. So this is the WBS here. All right, together with all of your coding. Okay, for example, this coding 1.6.4.3 is coming from 1.6.4 of testing. Okay, is coming from the 1.6 here, the integrations of your bicycle. Okay, so your bicycle here is the number 1. All right, so in order to complete your bicycle here, you need a frame set. We call those as the coding 1.1. You also need to assemble a crank set 1.2 together with the wheel 1.3. Okay, together with the 1.4 braking system, together with a shifting system. We call this system as 1.5. Okay, and then you need to integrate the concept, design, assembly, and testing with your bicycle. We call those as 1.6. Okay, and after that you need to integrate your project management, your scope, okay, your parameter, bill of material, and so on. Okay, with your project management, we call those as 1.7. Okay, so for each of 1.6, for example, you are required 4 different sub chapter. We call this as 1.6.1 as the concept, 1.6.2 as your bicycle design, 1.6.3 as your bicycle assembly. Okay, how you want to assemble, either you want to weld, or you want to use a bolt, or you want to use a rivet, up to you. Okay, and then after that 1.6.4 is how you want to test, okay, the performance, the capability of your bicycle. Okay, either you want to test the component, or you want to test the bicycle product itself, or you want to test the customer satisfaction. So all this we calling, okay, the 1.6.1, 0.6.2, 0.6.3, 0.6.4 is the coding. Okay, so once you work as engineer, okay, regularly, all of this number here, 1.6, 0.1, 0.2, 0.3, 0.4 here, is how people try to control, okay, by having a standard. We call those as ISO 9001. Okay, once you work as engineer, there is a lot of standard that will be practiced in your workplace. One of those, we call it as ISO 9001. 9001 is a standard, okay, to control all of this numbering. We call those as the quality system. Okay, quality system. All right, you will see this a lot. Okay, once you work as engineer, other than ISO 9000 that control the quality system, okay, we also have ISO 14000. Okay, 14001. This system is control for the environment system. Okay, dia nak jaga kebersihan. Okay, what kind of kebersihan, okay, that we are talking about? Either
The microphone mute.
Mikrofon sir termute.
Microphone sir mute.
okay, boleh dengar tak, Sam?
Boleh, Dok.
Alamak, rugi lah. Okay, sekejap. Saya share sebalik ya. Okay, boleh dengar eh?
Boleh.
Alright, so kat mana last tadi yang awak dengar tadi? Saya bercakap tadi.
1400 tu.
Okay. Alright, another system, quality system that you will see a lot once you work as engineer is ISO 14001. Okay, this is how people try to control the environmental regulation. Okay, either to the soil, okay, or to your monsoon drain, okay, water, all right, or to your apa lagi itu, air, udara, tanah, ya, tiga. Alright, so accordingly, once you work as engineer, if you're working for this ISO 14000, they will see how you control your incinerator, okay, your exhaust fan, okay, and then your soil, alright, how you control your effluent. Ada siapa-siapa tahu ke effluent? Tahu tak effluent ni apa benda dia?
Treatment.
Tak pernah tengok lagi effluent, okay? Effluent.
Water treatment.
Yeah, for the water treatment. You cannot release your suspended solid directly to the soil or to the monsoon drain without you doing the treatment. Most of the time, this effluent is you having what you call it as the aerobic system, and then the second one we call those as the anaerobic system. Anaerobic system. Okay, aerobic system you need to control your pollution by doing the suspended solid around 3 to 4 months. Okay, and then for this anaerobic here, you need to control another 1 month. Then after that, your suspended solid can be released to the environment. Okay, this is how once you work as engineer, other than quality, you also need to control the environment. And the third one that you also will be seeing a lot once you work as engineer, we call those as the ISO 18000. Okay, 18000 is for the safety. Okay, so this safety we will discuss later. Okay, how we can control, how we can minimize, okay, the safety concerns in your workplace. All right, so please bear in mind, once you work as engineer, these three ISO quality system 9000, 14000, and also 18000, you will see this a lot. Okay, so again, we're going back to this work breakdown structure. Okay, we try to define the communication channels and assist in coordinating the project elements. Okay, that's why once you work, let's say this is your bicycle here, we try to communicate between each of these assembly here. All right, and everybody will know, okay, what is their job, what is their task, what is their job scope, okay, and what is the bill of material or costing or time, okay, so that for each of the department will assemble their bicycle, okay, in time. Okay, so you will see this a lot. Kalau you boleh pergi ke Shimano Johor, okay, dia banyak pasang basikal yang mahal ni. Okay, alright, so another step here after that is you creating the work breakdown structure by you put your work package. Alright, this work package is the last, okay, the last parameter, output oriented, that you can identify the resources needed to complete a work package. Okay, dalam bahasa kasar dia, this is where you put all of your bill of material. Okay, and after that, okay, once you work as engineer, most of the time your bill of material will be put in the engineering drawing. Okay, macam mana you punya skill engineering drawing sekarang? You dah boleh baca tolerant? You boleh baca tak bill of material? You boleh baca tak you punya singkatan, who is the person responsible for each unit? Okay, berapa nak pakai bolt, berapa nak pakai nut, okay, how much that you want to use for your welding or whatsoever. Dah boleh baca belum engineering drawing? Boleh? Okay, you must make sure once you graduate you are capable, okay, to read the engineering drawing. Okay, those are what we call it as the basic skill, okay, for practitioner, for engineering practitioner, in the case for you as future mechanical engineers. Okay, I hope, okay, I hope you are capable to read it out, okay, without much problem. Kalau ada problem, if you have anything regards to engineering drawing, you can Google. Okay, inside the Google there's a lot of skill, okay, how you can read the engineering drawing. Okay, and also here this work package here is where your boss will try to identify, to monitor, or to seek out the milestone for each of activities. Okay, so if you work in the production, your boss will see those are become the milestone for the production. If you work with the maintenance, they will see, okay, this is the monitoring point for the maintenance team, and so on and so on and so on. Okay, so most of the time this work package here, okay, this is the work package. All right, So the WP is work package. Okay, WH, for example, here is the read write head. Okay, this is the last. Okay, frontier for your milestone for your work package. You will see this a lot once you work as engineer. If this is the work package for personal computer, then so be it. If this is a work package for the inlet manifold, for example, for your engine car, then let be it. Okay, so this will become what I call it as the structure of your work breakdown. Okay, and then after that, you will try to integrate this WBS with your own organization. For example, okay, this is an example here. Your organization. Okay, this is your organization. All right, and then after that, you will try to seek. Okay, if your circuit board here, either you want to design by your own, okay, or you want to purchase. Okay, so in the case of this kind of organizations here, your boss says that the circuit board should be designed internally, production internally, test internally, and the software should be integrated internally. Okay, you do not want to purchase. Okay, however, for the motor here, okay, your boss says that they do not want to design it, do not want to production it, do not want to test it, do not want to having their own software to control the motor. Okay, instead your boss says that he want to purchase. All right, so you also need to remember once you work as engineer, okay, you try to use as much as possible. Okay, I'm saying to you as much as possible the standard part. Okay, why? You need to assemble, you need to integrate your standard part. Okay, whatever that you having outside. Okay, in the market. Okay, I give you example. Awak perasan tak? Awak pakai kereta, dah ada yang beli kereta dah sekarang. Okay, ataupun ada yang pakai motor kan? Saya ambil contoh yang pakai kereta lah kan. What is the standard size for your car tire dah? 13 inci. Ya?
13 kan 16.
13, 14 betul. 15, 16, 17 betul.
Betul.
Yang paling murah apa? 13, 14, 15 kan? Yang paling murah.
14. Kancil.
Okay. Jadi this kind of tire size here is the standard, okay, that people use outside. All right. So once you got the standard, okay, the price is cheaper, and you also don't have much problem to assemble it. Okay. Together with this tire, you also have a rim there, standard rim. You have what is the standard rim that you use? 4 bolt, right? Ada yang pakai 5 bolt ataupun 6 bolt ke untuk you punya tayar? You punya rim. Biasa you pakai 4 kan? You punya bolt untuk you punya rim. Tak perasan eh? Tak boleh tengok eh? 4. So what is this? It is about what I call it as the standard assembly. Okay, standard part. Okay, you janganlah you design ataupun you buat you punya part tu, you punya komponen tu yang tak ada dalam standard, yang tak ada dalam market. Nanti susah you nak dapat spare part. Okay, so this call it as the provide a framework to summarize your work unit, and then you try to identify the unit responsible. Who is the organization's unit responsible? For example, there for the motor, there the team for the design, okay, don't have the responsible for the motor. Also, don't have the responsible for the production. Okay, the team from the test also don't have the responsible about the motor, but the team for the purchasing here will have total responsibility to purchase, and then to test, and then asking the production to assembly the motor to your product. All right. So this I call it as how the units, okay, will be ties with the organizations, and after that we try to at our best to control the cost. All right. So this is how people try to integrate the WBS with all of their level. Okay. Together with the second one, we call those as the work package, and the third one we try to control the organization. So you have 1, 2, okay, and then this is number 3. You will see this a lot once you work as engineer. Okay, how the people try to organize themselves in the workplace. Okay, and then in a very detailed way, you will see this a lot also. Okay, in your whiteboard. Okay, who is the person? Okay, the person, for example, the person 1 Richard, the person 1 is Dan, the person 3rd is Dave, the 4th person is Linda, the 5th person is Elizabeth. Okay, and then what is their task? Okay, for example, R here is responsible, direct. Okay, and S here is the support assist for each of the tasks here. All right, for example, the Richards, okay, the daily responsibility should be to identify the target customers, develop questionnaire, and finalize their questionnaire. All right, and after that, he also need to support, okay, other team to prepare the report draft. Okay, this what we call it as the project tip responsibility matrix. You will see this a lot, okay, in the production office, in the maintenance office, okay, once you work as engineer. So using this kind of schedule here, using this kind of project team responsibility to identifying tasks here, okay, is the main criteria that will be used by your boss to seek, okay, what is the milestone, what is the responsibility for each of the team, okay, so that he can clarify the extent or type of authority that can be exercised, okay, by each of these participants. Okay, and last, of course, we also discussed previously how people coding this WBS, okay, for the information system, okay, because this will make sure that people can get organized, people can get classified, people can see what is the bill or material, people will also see that the part or the product or the component, either you want to manufacture itself or you just want to assemble, or if you do not want to manufacture, you do not want to assemble, you just purchase it outside. Okay, anything to ask for now? Ada apa nak tanya sebelum saya sambung lagi? Okey, tak ada saya sambung lagi ya.
Okey, sir, boleh.
Alright. Okay, let's go for another slide share here. Okay. Okay. Can you see this slide now?
Yes, sir.
Yes.
Okay, this is other than WBS, this is how you as future engineer, you can control the activity, okay, in your work organizations. Okay, we call those here as the activity on nodes, NODES here. All right. So by using this activity on nodes, okay, you can create a list of, okay, a list of your project activity. This is your project activity here. Okay, this is the name for each. Okay, and after that, the dependencies of each of this activity, all right, to or between them. For example, here, activity C. What is activity C here? Before the activity C, the preceding activity should be E and B. Okay, for example, here. All right. So you must make sure before you can produce or you can measure the activity C, you must make sure that you finish activity B and also activity E. If one of these activity are not finished just yet, okay, activity C cannot be run as well. Okay, so you can put all together inside the table, and then you will see how people try to integrate this activity on nodes here, so that you will see after a time being, once you start the activity there, where or when, okay, the overall assembly or overall activities will be finished. For example, at the beginning here, you will put what is your man machine material method, okay, parameter that you will use, and then after that, maybe after 1 or 2 days, okay, your car production, okay, or your platform productions, or your assembly production can be achieved, okay, in what kind of time. Okay, let's see. All right. uh, Before we going further, I would like to clarify, okay, there is a few display activities, okay, that we need to understand. Okay, the first one, we call it as the earliest start time, okay, or we call those as the EST. Okay, this is where when can I start the activity? Okay, maybe at the first day here. All right, and then you also have the EFT. Okay, earliest finish time. Okay, when can I complete the activity at the earliest? You also have the latest start time. Okay, this is when is the latest possible date to start the activity. Okay, if I want to complete the project on time. And we also have the latest finish time. Okay, this is what I call it as when is the latest possible date, okay, to complete activity if I want to complete the project on time. All right, and after that, you have a D here. We call this as the duration. You also have the CBT, the cumulative buffer time. You also have what I call it as the BT, free buffer time. Okay, so first you will have your schedule. Okay, first you have your schedule. The second one, you have your activity on nodes. Okay, activity on nodes. What happened after activity A to activity B to activity C there. All right, and then you go to the end of your activity here. This is your end. This is your beginning. All right. So the third one, you must have your EST. You must have your earlier finish time. Okay. Late. Okay. Latest start time and the latest finish time. Okay. Then your calculation for these nodes will be completed. All right. So let's see how can we link. Okay. The example of these activities. All right. First, you need to define the dependencies of activities, okay, and then you should put your predecessor or successor activities, which you can link by the arrow. For example, here you have your activity name of booking a hotel, okay, room, okay. The date or location should be the activity number 1, okay, and then after that, the hotel booking is the activity number 2, arrival number 3, on-site offer, program approval, and even that starts should be your another activity. All right. So together with each of these activity, you have, okay, either the predecessor activity or the successor activity. In the case of this table, they give you the proceeding activity. Okay, and what is the normal time or days, okay, for each of those activity to complete. For example, here the date or locations here, this is the number 1 activity, okay, and the normal time, okay, to finish this activity is 1 day. Okay, for the hotel booking, this is the activity number 2. Okay, it is required 25 days, okay, to complete the overall activity. And the third one here is the arrival activity. Okay, it is requiring, all right, for 15 days to complete this activity. And this arrival activity is the third activities, okay, in overall activities. All right, so the proceedings of arrival or number 3 here is come from activity number 1 here. Okay, this is how people put the link activities. Let's see the example of number 6. Okay, what is number 6? Number 6 is send info to participant. Okay, all right, and it is require 10 days. Yeah, yeah. Wait a minute. Send info to, okay, so should be 10 here. Okay, send info. All right. And then for the on-site program here, should be only 1 days here. All right. So, all right. This send info to participant at number 6 here. Okay. It is required proceeding activity number 2. Number 2. Number 3 here. And number 4. Okay. Number 2, number 3, and number 4 activity should be finished before number 6 activity can be running. Okay, like this. All right. So if you fail to produce either number 2 or number 3 or number 4 activities, activity number 6, send info to participant, cannot be running as well. Okay. All right. So here. Okay, I just give this correction here. All right. All right. So after that, the step number 4 for this kind of activity on notes is what we call it as the forward planning. Okay. So the forward planning here is you try to calculate, okay, by going forward from number 1 here to number 2, okay, number 1 to number 3, number 1 to number 4, okay, and then number 2 to number 6. All right. Number 3 to number 6. Number 4, okay, either to number 5 or to number 6. Yeah. All right. And then number 6 and number 5, you calculate again so that you can put together with number 7. And then number 7 will end at the number 8. So what kind of calculation that are required to calculate here? All right. You will need to calculate the earliest start time. Okay, for example here, the activity number 1 here, the earliest start time is 0. Okay, is 0 here. All right, and then the earliest finish time, okay, here earliest finish time is the sum of EST here, all right, plus with the duration. So what is the duration for the number 1 here? 0 plus 1. Okay, so you got 1 day. Okay, that's what we put is your earliest finish time. Okay, and then after that, this earliest finish time, you put it to the earliest start time for each of the predecessor activity. For example, here the hotel booking here will start at 1. Okay, we'll start at 1. We'll start at 1. Okay, and then after that, you want to calculate the earliest finish time. Okay, so the earliest finish time for the hotel booking should be your earliest start time. Okay, plus with your duration. Okay, what is your earliest start time for the hotel booking? 1 day plus the 25 days. Okay, here. So you got a total of 26 days. Yeah. All right. The same is true for the arrival. 1 plus 15. Okay. Then you got 16 days. All right. For the on-site offer here, 1 plus 20. All right. Then you got 21. All right. So another obstacle that you need to confirm is for each of the activities send information to participant, it is require 3 kind of activity. What kind of activity there? Hotel booking, arrival, and also on-site offers. Okay, 3 different activities. So which EFT that you need to put in your send info to participant EST here? You need to put the highest EFT. Okay, for example, here you have 26 days, 16 days, and 21 days. You need to put the highest one. The highest one should be 26 from the hotel booking. So you put the 26 here to become your earliest start time for the activity number 6, send info to participant. And then after that, 26, okay, plus the 1 day here, you got 27 days. All right. And for the number 5 here, this is straightforward. Okay, you just use the 21. Okay, 21 plus the 10 days. Okay, you got 31 days. Okay, and then after that, you need to compare whoever is the biggest earliest finish time, either 21 or 27 days. Okay, the biggest should be 31. Then you put the 31 to this next activities, approval activities. Okay, so 31 will become your earlier start finish. Okay, earlier start finish for your approval activity. Okay, and then 31 days. Okay, you sum together with the approval activities. 30 days, you got 61. Okay, and then 61. Okay, you plus together with 5 here, you got your maximum days. Okay, to complete the overall project here is 66. Okay, now your going forward is finished. All right, the step number 4, forward planning, is finished. Let's see the step number 5. We call those as the backward planning. Okay, the backward planning means that you want to run back your activity going backward. Okay, up until day 0. All right, so the 66, you just put it here, 66 here, to become your late finish time. Okay, your late finish time, and then your late finish time 66 here, you minus your duration. What is your duration for the event start here? Should be 61. Okay, 61. So this 61, you just put it here. This will become your latest start time. Okay, so 61, you put it again here, all right, and then you minus your duration 30 days, you got 31, okay, and then you put your 31 as your late finish time for the activity number 6 and also activity number 5, okay, and then 31, okay, you minus the 10 here, you got 21 days, okay, 31, you minus the 1 here, you got 30 days, okay, okay, this will become quite tricky, all right, come to make it tricky for you. Why? Because for the activity number 4 here, there is two sources coming back, okay, activity number 5 and also activity number 6, okay, to fulfill your latest finish time. So what you need to do here, you need to use the lowest start time, okay, to bring back to your latest finish time of number 4 here. So what is the lowest here? Between 30 and 21. Okay, the lowest should be 21, then you put 21. Don't take the 30 here. All right, you need to put 21. Okay, so after that, the 21, okay, minus 20, you got 1. Okay, 30 here is straightforward. Minus the 15, you got 15. 30 here straightforward also, you minus 25, you got 5. Okay, and again here you see there is 3 sourcing come into your activity number 1. So you put the lowest LST, okay, the lowest here is either 5, 15 or 1, and then you take 1 because 1 is the lowest LST, okay, available in your latest start time for the activity. Then you put 1 here, okay, you minus 1, you got 0 here. All right, so almost ready, okay, your step number 4 and step number 5. Step number 4 is a forward planning, okay, you want to know what is your earlier start finish and also the earliest what we call it for the EFT here, and also here you see that step number 5, okay, you will try to calculate the latest finish time, okay, latest finish time up until your latest start time, okay, and then you will see your numbering here is almost complete, okay, one is going forward, one is going backward. All right, so what happened after this? Okay, the number 6 here is you try to calculate the buffer time. Okay, so the next step here is to identify the cumulative buffer time and also free buffer time. Okay, the cumulative buffer time is latest start finish. Okay, latest start time minus the earliest start time for each of those activity. Let's see here, activity number 6. Where is activity number 6 here? Activity number 6 is here. All right. You minus the LST minus the EST. All right. This is your LST 30. Okay. Minus the EST. What is your EST here? It is 26. Okay. So you got 4 here. 4 is your CBT or cumulative buffer time, and then you put it here 4. Okay, the same is true for activity number 5 here. 21 minus the 21 here, you got 0. Okay, let's see others. Okay, 15. Okay, minus the 1 here. Let's start finish minus the 1 here. You'll see that your CBT should be 14. Okay, and again here, let's see you see the activity number 2. You got 5 minus 1. Okay, minus 1 here, you will see that your cumulative buffer time is 4. Alright, so what happened here? Once you got this buffer time, cumulative buffer time, you will see it is indicator, okay, how this buffer time can jeopardize your project completion. Remember, jeopardize your overall project completion. All right. So for the hotel booking, you have 4 days. For the arrival, you have 14 days. Okay. For the send info to participant, you have 4 days. Okay. But for other activity, okay, you have zero value. You cannot delay this. This will become very critical. If you delay this, the overall project will cannot be complete. Okay. And the second free buffer time that you need to understand is BT, or we call it those as the buffer time. Let's see what is this. Formula for the buffer time is EST for the successor activity minus the current activity on EFT. Okay, so EST minus the EFT. For example, here, this is the EST for the previous activity, and this is the EFT, okay, EFT for the current activity. So 26 minus 16, okay, 26 minus 16, you got 10 here. All right, 26 minus 26, you got 0. Okay, and then after that, this one, 21 minus 21, you got 0 here. Okay, so this I call it as the free buffer time. Okay, you must make also remember, if you have one or more than one successor, you take the lowest EST. Okay, the lowest EST. For example, here, this is where do we have example here? This is 21, this is 10, this 26 here. All right. So if you have, for example, activity number 4, this is activity number 4 here. You have 2 successor. Okay, number 5 and also number 6. Okay, the lowest one is 21. Instead of 26, the lowest is 21. 21 is your calculation for the free buffer time. 21 minus 21, you got 0 there. So after you complete overall free buffer time here, you will see that if there is delay, it will impact on the completion time of next activity. Remember, buffer time free is for the next activity. The cumulative buffer time is for overall project completion. Okay, it is not the same. All right, and the last one, okay, for you as engineers, you need to determine the critical parts. What is the critical parts? This is the longest duration from starting the project to the finish. Okay, if possible, you need to find whoever flow of activities that having CVT equal to buffer time equal to 0. In the case of here, all right, this is your critical path, okay, because it offer you 0 CVT and also 0 buffer time. All right, here, all right, finish. Okay, so this critical path will determine the minimum project durations and also help you to devise countermeasures from the start. Okay, important for you to close eye on the activities that have the critical paths. Why? If you have problem for this kind of this activity here, flow activity here, overall project, okay, will be jeopardized. You have the problem. to finish your project. Okay, this is the critical part. Okay, you need to make sure you finish on time. Okay, ada apa nak tanya setakat ni? Simple je ni, tapi you kena berlatih lah. Okay, boleh ya? Yang ni saya ada bagi latihan sikit. Kalau you nak buat, saya ada letak dekat kalam. Okay, untuk you punya slide ni. Kalau you nak berlatih buat. Okay, biasa dia waktu you kerja nanti, you kan ada team. We call those team as production planning control. Okay, this guy will use this kind of information, the scheduling information, the critical path information, the buffer time information, so that he can schedule later for all of production team, all of the maintenance team, all of the R&D team to fulfill, okay, following the schedule. Okay, that's why we hire them, production planning control team, to assist production, maintenance, quality control, quality assurance team, whatsoever that, according to the projection time. Okay, so if saya beritahu lagi sekali, if you are lucky, in some cases, okay, there is no production planning control team in your workplace, in your work site. So what happened? Engineer lah kena buat sebenarnya. Kalau you tak ada tim PPC, memang you kena buat sendiri. Okay, kita boleh katakan padan muka lah sebenarnya. Tapi at least kurang-kurangnya knowledge sharing yang saya bagi hari ni, you capable to understand and then you can apply directly, no problem. If you do not want to make it manually, you can use Microsoft Project, okay, to solve your project planning here. Okay, ada apa nak tanya setakat ni?
Midterm ada masuk yang tu ke sir?
Ya, midterm saya nak masukkan ni. Activity or not ni. Memang saya suka masukkan dalam you punya midterm. Okay.
Okey sikit daripada tadi sir. Okey.
Ya, ada lagi nak tanya?
So,
Ya.
Tak ada.
midterm bila tu?
Hari Rabu minggu depan. Waktu kelas.
Thank you, sir.
Okay. Berakhir sampai tajuk yang hari ni ya.
Midterm hari Rabu sir?
Ya, hari Rabu pukul 11.
Oh, okay, thank you sir.
Okay. Alright, ada apa lagi? Okay.
Tak ada sir.
Alright, kalau tak ada boleh kita pergi lunch lah, makan. Okay, dah pukul 12 ni. Lapar dah tu masing-masing. Kita jumpa balik hari Jumaat ni ya.
Baik sir.
Alright.
Thank you.
Thank you sir. See you again
Thank you sir.
next
Thank
Friday.
you sir.
Alright, thank you sir.
Have a nice day, sir.
Thank you sir. Have a nice day.
Okay.